You know, many of us have this showpiece in our house. Have you ever noticed that this showpiece, the light is at the bottom, but when I hold it like this, I can see the light on the top. Yes, the light kind of travels through the fibers. That's a very crazy phenomena we are about to learn today. And it's not just something which we see around us in showpieces or somewhere else. This is something which the nature even shows us. Have you ever seen this? You are moving in a summer noon. गर्मी का मौसम है ना, धूप बहुत तेज है, आप रोड पे जा रहे हो और आपको दूर लगता है यार पानी पड़ा हुआ है शायद, यार, you feel like there is water on the road, or if you are in desert, you feel like is there a lake, right? है ना, लगता है ना? Yes. This is the magic of total internal reflection, and this is something we are about to learn today in the chapter of light reflection and refraction. So, welcome everybody. Good evening, good morning. It doesn't matter because I'm happy you are here. And you are here means you want to learn about this. So, this is extremely important from ICSE point of view also and from competitive perspectives also, right? Because this is something which is very important. Very commonly asked in examinations, right? So, let's learn everything about total internal reflection. Now, नाम काफी सिंपल है ना, टोटल इंटरनल रिफ्लेक्शन, मतलब टोटल सारी लाइट रिफ्लेक्ट करती है. Yes, in a way you can say that. We always know reflection happens in mirrors, yes, but if light is traveling from one medium to another, it bends. Why? Because the refractive index changes, right? The speed of light changes. Now, let me ask you something. Will the laser light that scuba divers use always undergo refraction? I know some of you are saying right now, है ना, तुम लोग कुछ लोग बोल रहे हो that not if it is normal, not if it is normal, है ना? You know that if light ray passes normally from the interface, it doesn't bend, correct? है ना? हमको पता है ये बात, and I can show it to you over here also. Notice. See, the light ray is kind of bending, right? है ना? Yes. But there is one more way in which we can say there's no refraction happening, and that is where the picture begins, I would say. अब ध्यान से देखो. Total internal reflection. The one major condition is light ray should be traveling from a denser medium to a rarer medium, means from a medium whose refractive index is higher compared to the medium in which it's going, which is a low refractive index medium, right? A rarer medium. इसके अंदर, when light ray passes in this manner, what happens? It bends away from normal, right? Denser to rarer, it will bend away from normal. We all know that. Yes, you're right. लेकिन if you notice, अगर you keep increasing this angle of incidence, ये वाला angle, ना, अगर आप इस एंगल को इंक्रीज करते जाओगे, then what will happen? Think about it. If you keep increasing this angle, what will happen? Light ray is bending away from normal. There will be a point where this angle will be so much that the light getting refracted will be at 90 degrees. Angle of refraction हो जाएगा 90 degrees. This particular angle for which the angle of refraction is 90 degrees is called as critical angle. इसको बोलते हैं हम critical angle, है ना? नाम भी अच्छा ही है. Critical, कुछ अलग, कुछ different, है ना? Critical means, oh, that angle जिसपे कि angle of refraction हमारा maximum हो जाए, that is 90 degrees. Okay, fine, ठीक है? That is called as critical angle. लेकिन मजा पता है क्या बात है? The fun begins if you keep increasing the angle of incidence. If you further increase the angle of incidence, you will notice total internal reflection. This is I, this is R, and I equals R. That's internal reflection. When does it happen? When the angle of incidence is more than the critical angle. That's where total internal reflection happens. और ये वो चीज़ है which all of you can experience sitting at your home. Let me tell you, अगर कुछ नहीं है, laser भी नहीं है, you have nothing, just take a glass of water and just look at it from below. What you will see is a shiny surface. Now you will see a nice shiny surface. Why? That layer is acting like mirror. That's total internal reflection only. And I can show it to you over here also. If you notice, ध्यान से देखो, अगर लेजर है बहुत ही अच्छा है, you can just do it very nicely. Now focus over here, देखो, you can see the light is going back into the water, right? है ना? This is called as reflection, and in this case I would say this is total internal reflection. I have even done a nice shot on this which you will get it very soon. Relax, relax, okay? Alright, so is it clear what is total internal reflection? It is the light travels from denser to rarer medium. If the angle of incidence is more than the critical angle, it gets totally internally reflected. And why total? Because 99.9% of lights get internally reflected. Reflection in mirrors, we see it looks like कि बहुत अच्छा reflection होता होगा, what, you know what? But that's also absorbs the intensity of light. But this is even better than that. So TIR के अंदर बहुत ज़्यादा light reflect होती है, right? Absorption losses बहुत कम होते हैं. That's why we call it the total internal reflection. All right. Now, conditions. First condition, very important, denser to rarer medium. Extremely important. Light should be traveling from denser to rarer medium and angle of incidence should be more than the critical angle. This is going to be your answer when this question comes in front of you in examinations. Okay. अब थोड़ा maths कर लेते हैं इसमें. Okay. If you want to derive the formula of critical angle, it's very easy. Use Snell's law, na? Light is going from denser to rarer medium. Okay. Let's say this is water which has a refractive index of NW, right? This is NW and this is air, refractive index of, let's say, N air. Fine. Apply Snell's law, and I have taught this to you, how to apply Snell's law in a very nice manner. And apply the Snell's law for this condition, okay? For this condition, you are supposed to apply Snell's law. Angle of refraction कितना है? It is 90 degrees. Incidence कितना है? I don't know, it must be something. I होगा, IC बोल देते हैं उसको, ठीक है? चलो, NW into IC. Refractive index of water multiplied by the sine of this angle, and this angle is what? It is critical angle. Why? Because angle of refraction 90 degrees, right? So NW into the sine of critical angle, right? This angle is equal to what? Refractive index of air multiplied by the sine of this angle, and this angle is how much? 90 degrees, is equal to NA into sine of 90 degrees, and sine of 90 is what? It is 1. So sine 90 is 1. So I can say NW into sine IC is equal to NA. Sine of IC is equal to NA upon NW. Refractive index of air upon refractive index of water. If you just want to generalize it, है ना? अगर कोई भी medium air के साथ compare करोगे, so in very simple words you can say 1 upon mu becomes the answer, right? With respect to air की बात कर रहे हैं. Alright, so that's why this is the derivation for the critical angle. So, very good. Now, if we move forward, let's see. I have a question for you now. I hope you didn't see the answer. Alright, come on. See, in total internal reflection, the value of critical angle will be maximum when light passes through what? And it's a very nice question to answer. Come on. In total internal reflection, the value of critical angle will be maximum. Maximum. When light passes through and mu of glass is given to you 1.5, mu of air is given to you 1, mu of diamond is 2.4 and mu of water is 1.33. Come on, think about it. We just derived the formula. Yes, we just derived the formula. Light is going from denser to rarer medium. Sine of IC is equal to what? Refractive index of rarer medium upon refractive index of denser medium. Clear? This is what we just did. Okay. Think about it. Come on, come on, come on. I want the answers right now. I want the answers. From diamond to air. Let's see. Sine of IC will be how much? Diamond to air, NA upon ND, which means NA कितना है? 1 upon 2.4. Okay. यानी कि if this value comes out to be less, the angle will be less. सोच के देखो, sine में क्या होता है? Sine 0 degree, sine 30 degrees, 1 by 2, sine 45 degrees, 1 by root 2, sine 60 degrees, root 3 by, increase होता है ना? As you increase the angle, the sine value also increases. यानी कि अगर sine value is less, the angle will be less. So you want this ratio to be least. ये कम से कम होना चाहिए for your angle to be maximum. Glass to air कर लेते हैं. sine of IC will be how much? NA upon NG. सोच के देखो A कितना है 1 upon G कितना है 1.5. ओके, लास्ट में लिख लेते हैं. इसका आ रहा है for this it's coming out to be water to air, right? 1 upon water कितना है 1.33. For this one it's how much 1 upon yes. Oh, from glass to water, by the way, from glass to water means numerator is the refractive index of rarer medium. So N of water upon N of glass. So this is what 1.33 upon 1.5. Now you tell me which ratio is the least. सबसे कम कौन सा है ratio? Compare करो. Yes, you got the right answer. This is the least ratio. अच्छा, एक और simple फंडा बता देता हूं मैं. Critical angle. If the difference in the refractive index, now, or I would say the ratio of refractive index, अगर बहुत denser medium से बहुत rarer medium में कोई light ray जाएगी, critical angle उसका उतना ही कम हो जाएगा, right? Correct? So think about it. अगर the ratio of refractive index is least, the critical angle will be maximum, क्योंकि bending कम हो रहा है. Critical angle ज़्यादा होने का मतलब क्या है? Light में bending कम हो रहा है. Bending कम होता है, कब होता है? When is the bending less? When refractive index is less. So in a way you can think about like this. If refractive index increases, more will be the bending, more will be the effects of the difference in the medium. मतलब critical angle तो कम हो जाएगा. कम angle पे ही light 90 degree हो जाएगा, right? अगर refractive index कम होगा, then what will happen? The effect or the bending will be less. इसका मतलब मेरे को बहुत bend करना पड़ेगा to make it 90 degrees. Okay, ठीक है, fine. Just improve your logic like this. Very good. So that's why the correct answer is from glass to water. Or let's talk about the nature. Nature में कैसे होता है यार? I mean, why do you see that there is a lake? Let me tell you. Let's think about it. If you see the reflection of the sky somewhere, you feel like it's water, and your brain tells you that is a lake, है ना? So basically, the thing that you feel like it's a lake or it's water is just what? Reflection of the sky coming to your eyes. अब सोचो, reflection. How is it related to TIR? That's what. First condition, light should travel from denser to rarer medium. इसका मतलब, what can we say? इसका मतलब हुआ that the bottom should be low refractive index and the upper one should be high refractive index. True, है ना? सोचिए बताओ. It's a hot summer day. ज़मीन hot है. So the air which is closer to the surface is also hot, means it has low refractive index. The air above it will have more refractive index. Why? Because it is away from the surface. जो ज़मीन को touch करेगा वो गर्म हो जाएगा. If it is hot, it has low refractive index. So in a way we can say light ray while traveling in this direction, is actually moving from denser to rarer, or you can say denser to rarer, है ना? Light ray is moving denser to rarer. So rarest कौन सा है? The one which is touching the surface, right? That layer of air is the rarest, correct? Right? So that's why. Let's see what happens. I can say, let's say light ray goes from denser to rarer, it bends away from normal. Again, it bends away from normal. This is one more layer. It tries to bend away from normal, but now it is more than critical angle. This angle is more than the critical angle. So what happens? Reflection happens. And when, let's say, your eye sees this reflection, with your brain, it says the light is coming in straight lines. And that's how you get to see the image of the tree on the surface, and you feel like it's water. So in a very simple words, you can say it's happening because of TIR, right? We call it the mirage, right? Light ray is going from denser to rarer mediums. Why? Because the surface or the layer of air closer to the ground is rarer medium, and above that it's a denser, right? It's a denser medium. So that's why. In the end, at one point, the angle of incidence becomes more than the critical angle, and it kind of reflects, and when it reaches your eyes, it says like this, okay? Fine? Alright, now, Few other applications of TIR which are quite easy and all of you should know it. It's what? One is mirage, in binoculars, in diamonds, and that's why diamonds shine. है ना? ऐसा लगता है sparkle कर रहा है. That is what TIR. Optical fiber. इतना speed में जो net चल रहा है आजकल. How? Optical fibers. It's a very important technology where you send signals or information using light. Yes. Bike reflectors. We just learned about this. So, with this, we have learned a lot about TIR. This is the plan which we have given to you, right? You follow this plan because this is exactly what we are also following. And if you believe that you learned something interesting today in some interesting manner, I want you to like this session right now and subscribe to the channel because we'll keep coming with more such sessions. And yes, I know you wish to see them again. See you next time. Like, share, and subscribe. Take care.